everybody. Let's start with the question. Who here in the audience, one is production on Docker? See that almost only nobody. See a few hands. So a little about me. My name, as I said, is Nitsan Zohar. I'm a front-end tech lead at Next Insurance. More than 11 years experience as developer. Last 7 years in Angular and AngularJS, of course. In the last year, I focused more on the info side of our Angular. I have 2 kids and 1 wife.
Only one?
You can see my Twitter and my LinkedIn. So the agenda for today. We'll start with some basic Docker. What is Docker? Why Docker? Docker terminology, Docker architecture, and Dockerfile example, and I will finish with some demo of Docker 1. So, what is Docker? Docker is an open platform for developing, shipping, and running application. Docker enables you to bundle application and its dependencies and ship everything out as one package, which then can be deployed. So, why to use Docker? In my opinion, there are a lot of reasons why to use Docker. I will name a few. Fast onboarding and develop. An example for onboarding, you usually need to read a long document, maybe some README file. Then you need to install all the dependencies. For example, MySQL, then import all the schemas. Maybe you need to change the port. You need to set all the configuration. Then you need maybe to install some backend service and configure it also. And of course, you usually need to install some global auth and add tokens to your environment. With Docker, it's very simple. You just need to Docker run your MySQL, Docker run your backend service, and your environment is ready. Isolate the environment. Docker containers are lightweight and contains everything you need to run application. So you do not need to rely on what currently installed on your host. For example, if one of the Docker on your machine needs Node.js version 8, but your currently version is the last version, there is no problem. The Docker holds all the dependencies inside of it. Fast deployment. Docker containers are known for decreasing deployment time. We recently switched to a Docker deploy in one of our services. Let's see the result. Before the Docker, in our pipeline, we have 9 minutes to deploy to production and 9 minutes to deploy to staging. In total of 19 minutes. With Docker, the deploy time was 1.5 minutes, so it's 2 minutes. So it saves us 15 minutes in each one. Ability to run anywhere. Docker eliminates the work on my machine. If the application works on your development machine, it can run a function the same way on another machine. And microservices and scaling. Docker is a great solution for microservices. Each service can run on a different Docker container, and you also scale up if you need more resource. Let's understand some basic concept in Docker. Dockerfile. Dockerfile is a text document that contains instructions to assemble an image. Docker image is a read-only template that contains a set of instructions for creating a container that can run on a Docker platform. And Docker container is a unit of software that can package up a code and all the dependencies so the application could run. Let's talk about architecture of Docker to understand how it works. You can see Docker client, Docker server, and Docker registry. Docker uses client-server architecture. The Docker clients talk to the Docker server, also called Docker engine, using a RESTful API. The Docker daemon, which is a part of the Docker engine, does the heavy lifting of building and running Docker container. For example, if you want to start a Docker service with Ubuntu Redis or Nginx, for example, you run the Docker pull command. The Docker pull download the image from the registry. The registry is like a bank of images. It downloads the image to the Docker server. Thank you. And when you want to run the Docker, you run the Docker run command, and it will run the Docker image into the Docker container. My application is a small application. In order to play with the Dockerfile, I've tested it on my app. My app is Angular 12 with 2 pages, 3 components, and 3 services. My server side is Node 14 with 1 file of app.ts of TypeScript. Let's see a demo of the application. So this is the application. This is the admin form of a Waffle CSV. You can choose file of CSV. I have a shortcut. I add a demo file with 7 names. I can change the URL. I can change the button text, and I can change also the color. So this is the waffle. I can click start, and the winner is GRPK is a winner. I will some Barca fan also. Nice in this season.
That's because Messi is not part of the Boston.
Yeah. So this is the first Docker file. Let's understand some instruction of the Docker. First, each Docker file starts with the form instruction. The form takes the base image. In my case, because my server is Node 14, I took the Node 14 Alpine version. The Alpine is the smallest version, which holds only the core files of the node. Then I'm setting the working directory. My app will be in the app folder. Then I'm running the npm install. First, I'm copying the package in a package log.json to my app folder. Then I'm running the npm install. Then I'm copying the project file. The dot is the current project, is actually my repo. Then I'm building the server side. My server is TypeScript, so I need to build it. And also, of course, build the Angular side with the npm1 build. And open the port of the node. This is the port of the node. And last thing, at the entry point, when I will run this Docker with Docker 1, it will start the npm start. This will start my node. So, in this first Docker file, my build time was almost 4.5 minutes. The npm install time was 89 seconds. And the image size is 552 megs. This is a lot of very small application. You see, I have only 2 pages in a small server side. So our goal, we have 2 goals. One of them is to reduce the image size, and the second one is to improve the Docker build time. To reduce the image size, I found out that there is a Docker ignore that excludes files and directories that match the patterns, very similar to git ignore. When I add this file, and this is the list of the folders, for example, I don't need Cypress for a folder, I don't need the dist and the node modules because I'm running the npm install and the npm build. To improve the Docker build time, I found out that the 2 longest operations was, one of them is the npm install, and the second is the npm1 build. To improve the npm install, I found out that I can use the npm clean install with 2 flags of the prefer offline and no audit, and you can save up to 53 faster than npm install in a clean workspace on every build. Because my pipeline is a clean workspace, this should help. About the npm1 build, Angular 12 already optimized, but as you already heard in the other talks, the next version of Angular just been released. I check it on the RC1 version, and the time was improvement from 55 seconds to 35 seconds. This is improvement of 36%. So in the next version of my Dockerfile, the first thing that I add the Docker ignore file, and the second, I add the npm with a clean install and the 2 flags. You can see the changes in the blue border. I didn't update the Angular to the next version because I check it on the RC version, and I don't want to work on the RC version. So the improvement in the time was, the build time was, the improvement was improved by 37%. The npm install phase took me now only 64 seconds, 28% of improvement, and also the image size is the same percent. But I found out that the node module is the biggest folder, it's the same. How can I improve the node modules folder? I guess some of you already know that node modules is the heaviest object in the universe. How can we improve it in our Docker image? I found out that I can use the npm prune production. The npm prune production will remove all the dev dependencies from my node modules folder. For example, I don't need all the tests, I don't need all the Angular dev kit and all the cycles, for example. I can remove it. So let's add the command after the build, because the build needs all the dev dependencies. And it should, when my node modules folder should be smaller. But when I check it, I saw that the build time was took me 8% more. It's okay because I had instruction, but the image size is the same. Why is it the same? The reason is that the same is the Docker layers. Docker image consists of several layers. What are those layers? Each layer is an image itself. Each layer stores the changes compared to the image it's based on. Each instruction in Dockerfile results a layer, except for multi-stage builds. And each layer skips build steps which have no change. This is the Docker cache. So what is multi-stage builds? Multi-stage builds enable you to create smaller images with better caching. And for me, it was a game changer. So in the next version of the Dockerfile, I changed it to multi-stage build. Each instruction in the Docker creates a layer. For example, the from is a layer, the work div is layer, the copy is a layer, and so on. Each layer stores the changes compared to the last layer, so the image gets bigger with each layer. When you write a from command, it will init all the layers, and the image image will contain only the last stage of layer. So in my example, you can see there is the first stage is the build stage. I'm doing the npm install and the build. And the second stage is from the from node 14 alpha. And again, this version I have an alias to the first stage as builder, and I can copy files from the first stage to the second stage. So with this version, my build time is now only 2 minutes, 28 minutes. This is an improvement of 18%. And the image size is now only 56 mega. The last bullet is about the Docker cache. When you understand it, you can use it. So in the next version of my Dockerfile, I remove the copy of all of my repo, and I copy only the relevant files and folders. For example, I copy only the server side, and then I build it. Then I copy the client side, the SRC folder of the Angular, and the relevant file that I need for the build, and one in the build. And this will improve the cache, because if there is a change in another file, before this, for example, if you change the README file, you lost all the cache. But after this change, you will have the Docker cache, because you copy only the relevant folders. So the build time is the same, the image size is the same, but now the second build is only 2.5 seconds because of the Docker cache. So I was happy. My Docker image is small. My build time is fast. I think I was done. But then I talked with somebody from our DevOps, and he told me, don't run container as a root. Attacker is able to invoke with the user who owns the application process. The default user of the Dockerfile is root. When you start an application on the Dockerfile without changing the user, and an attacker can gain access to all of your Dockerfile. You can change the user to user node. The base image of node comes with user node. Then the second thing you need to do is to change the ownership of the folders. And now the build time is the same, the image size is the same, but you're more secure. Unit test. Every developer loves to write unit tests. So let's add them to our Dockerfile. First, you need to add the Chromium, so it will be able to run on the unit test. The second, you need to add the environment of the Chrome build, and then you need to add the npm1 test. I did it before the build, because if my test is failing, I don't have reason to run the build. You just need to also add 4 flags in the karma config of the Chrome headless. Let's see a demo. Okay, this is the last Dockerfile. You can see here the Chromium. You can see the npm install with the 2 flags. You can see the improvement of the cache. I'm copying the server side, the server folder, one in the server build, copy the client side with the files of the build, one in the client unit test, one in the build, clean the node modules from the dev dependencies, and starting the new stage of the multi-stage, changing the user to node, change the ownership of the folder to the node user, and start the entry point. Let's see. I will build the Docker. The Docker command is docker build -t csv waffle. This is my name. This is v7. I will build it to my local machine. Let's run it. So because I already ran my Docker, you can see it with the cache. It took me only 2.2 seconds. Those are all the layers. You can see also the cache in each of the lines. Let's start the Docker. This is the one Docker command. The node is, I'm running on port 80 on my localhost. You check it. Let's run the Docker command. And now my Docker is running on my local machine. Let's zoom in. And let's go to localhost. And this is the application on my local machine on Docker. Working the same. Let's see now with our winner. Now the winner is, again, Jared Piquet. I will show you that it can be different. Just not Piquet, not Piquet. Busquets, okay. Busquets is okay. Some takeaways. First, try Docker. For me, it was really fun. Second, use multi-stage builds. For me, as I said, it was a game changer. And always try to improve. I thought in the first version of my Docker that I have a Docker and it was ready, and I always found a way to improve it. Thank you.